So, final chapter of the book, chapter 12, we were talking about the future of data systems. And so this chapter was kind of the author's predictions of what's going to happen with future systems, what they're going to look like, what are their characteristics going to be. For reference, though, this book was from 2017, so obviously some of his predictions might have changed since then, potentially, or already been proven false in various different ways. Um, we're just basically wrapping up everything. So at the beginning, the first chapter, we were looking at definitions of reliable, scalable, maintainable systems. And so looking at this chapter, we're trying to understand what actually goes into place in order to make all of those things happen. So the first section, looking at data integration, basically what he's saying is we have a lot of different technologies. No one fits perfectly for any scenario, basically. There's always lots of different options, and you can end up with multiple different solutions that are pieced together in order to achieve your goal. Every time, basically, you're going to have to evaluate a bunch of different solutions and figure out what's best for you. And you also have to be kind of critical and look at all of the stuff that we've looked at in the previous chapter in order to determine which one is specifically right for your scenario. And you have to have a critical eye because obviously vendors aren't going to explicitly say, here's all of the things that our product doesn't do. So you have to kind of be aware of the stuff that they might be omitting. They talked about combining specialized tools by deriving data. So they talk a lot about reading and writing data, but you might have some data that you write, and then you might have some secondary process where you do some processing on top of the data, and then you get a derived view of that. And then you can use that again for different read operations or different write operations down the line. And so there's different trade-offs between how complex it is to actually write your data and how complex it is to read your data. And you have lots of different potentially in between states with that derived data. And along with that, when you're going through the different layers of things, there can be a lot of different constraints that are added. So we've talked about in the past eventual consistency, read on write, and various different things like that. The previous two chapters, we've looked at batch and stream processing. And in this chapter, he's kind of bringing it all together and saying, well, they aren't necessarily two entirely separate things. A lot of systems now use both in various different regards, and you might have to integrate them together in order to achieve your goal. So they talk about creating derived data sets for easier read operations, and it might be separate from your write operations. So you can have two separate systems going at the same time, potentially even operating on the same source data in order to format it in different ways so it can be utilized differently by different organizations within the company or any number of different things. One of the things they talked about was that derived views allow gradual evolution. So if you have some source data and then you have a derived view that's used by some other process, you can potentially update that derived view fairly easily by just saying, okay, update this code or update this query or update something else. And then the downstream stuff can be updated more easily rather than actually changing the source data that might have been stored in a way that's not conducive to something. Then they talked about the Lambda approach. So you can use a stream processor and it's making approximate updates as new data comes in and new things get changed. And then you can have a batch processor go over it after the fact and actually do the exact correct derived versions potentially. One of the things they brought up was that maintaining both of them can be problematic because then you have to maintain a batch system and a stream system at the same time, and they might have different issues. And when you make updates, you have to update both in parallel potentially. I see the chat is going. Are there any questions, comments?
No, nothing. Nothing you need to answer.
Okay.
Nothing really book related.
Then they were talking about unbundling databases. And so they were talking about how Unix and relational databases have different approaches. So one of them is sort of a low level hardware abstraction, and the other one is more high level. You can just say basically grab this data and it'll go through the optimizers and all the other stuff, and it will just do the query that you asked for and possibly do a whole bunch of stuff in the back end that you didn't explicitly state. Then they talked about composing data storage technologies. So they laid out kind of two different futures for the way that things could be done in the future. So they were talking about federated databases for unifying reads and unbundled databases for unifying writes. So we kind of proposed this scenario where you eventually have a unified query language. So say you have all of these different databases in your organization, and you just want to query a certain bit of information, or you want to do some aggregation, or you want to do some sort of read operation. In some imaginary future, you could have a unified query language where you just have basically a whole pool of data, and you just say, I want to pull this data out, and it's actually pulling from multiple different databases and multiple different sources, and maybe even a derived view or something like that. And it will just automatically grab it. You don't have to actually say, I want to point it at this database and specifically pull it out. And then they talked about unified writes, which is kind of just the same thing, but on the flip side. So it makes it so your index maintenance and keeping track of all of that stuff across multiple different systems, you don't have to actually manually keep track of or write application code yourself. It's just automatically synchronized across all of the different databases. He mentioned that it's definitely a complicated problem. You can't just have SQL and all kinds of other systems automatically be synchronized across an entire organization, but it is something that is potentially possible because a lot of them have a somewhat similar common language, and you can do mapping between them, but it might be a significant amount of work until other things get built on top to make that kind of seamless integration possible. They mentioned that things are tending to push towards event logs instead of transactions, and that kind of changes some of the assumptions in terms of, or the way things operate in terms of consistency, but it also allows much more flexibility. And they were kind of pointing out that if you are completely reliant on transactions, then you have greater possibility of faults occurring and bringing down a whole system. If you just use event logs, then you can have the possibility of temporary outages that you can actually recover from more easily when systems come back online. They mentioned that the goal of unbundling isn't to necessarily compete on performance. If you just have a single database, it will likely still be the most performant thing that you can find, but you might only be able to query it in certain ways, or you might only be able to write to it in certain ways. And so that process of unbundling, you might be able to get the advantages of multiple different things, and you might have greater flexibility in what operations you want to do. So they were saying that the focus is really on breadth rather than depth. It's getting multiple tools to work together well in order to do all of the things that they're good at, rather than just having one thing that's able to do everything perfectly. One example that they used that I thought was kind of interesting was they were comparing some of the stuff that we do to just spreadsheets, and how spreadsheet, you update a formula, you update some data, and automatically all of the related stuff will just automatically get updated. So if this cell changes that cell and that cell changes another cell, it will just do the whole chain of operations. And you don't necessarily have to do anything specific in order to make that happen. It's just automatic. And so they were saying that that's kind of where they see databases and data applications going in the future, where things are kind of integrated in this way where you update one thing and it will just automatically trigger all of the changes down the line, and you won't have to do it all manually yourself. They were mentioning that right now, most of the stuff in terms of data applications is built with the web in mind, where we have the request response paradigm and everything is assumed to be stateless. So if a single server goes down, you don't really lose anything. You just pull up another server. But they were kind of pointing to the future potentially of where that changes a bit and state is a bit more active. And so I wasn't sure I totally followed that train of thought. They mentioned some of the new frameworks allow for certain things regarding state management. They were talking about some of the new Facebook stuff, but I don't really have a full grasp on that end of things. One of the things they mentioned though is an exchange rate example. So you have a store and you do business internationally, and every time you make a sale to someone outside of the country, you have to do some exchange procedure. And so one way of solving it is someone makes a purchase, and then that purchase, the server goes and asks an exchange what the current exchange rate is, and then gets that response back, and then actually does the conversion from one currency to another, basically. But the problem with that is you're doing a request for every single transaction that you have. And so an alternate approach, in order to minimize the amount of traffic to that exchange server, is to have the exchange server basically push an update to the server that's actually making the transaction, and then every time that it has to make that conversion, it just already has the most up-to-date thing, so it's already on the system. It doesn't actually have to do a round trip of asking for the exchange rate, getting the exchange rate back, and then doing the conversion after, and it makes it a lot faster potentially, and it minimizes the amount of requests. Then they were talking about aiming for correctness. So they were kind of saying that a lot of applications are moving away from the assumption or the need of consistency. So obviously you don't want your data corrupted, but it's not that big of a deal if a tweet shows up in someone's feed late, for example. And so there's a lot of applications now where it just doesn't really matter that you have immediate consistency. And when you relax that constraint, you can be a lot more flexible, and you can possibly have more performance too. And another thing that they were pointing out was there's been some experiments, and even all of these systems that have all of these guarantees, the consistency kind of falls apart when you have super high concurrency anyways. If you are really pushing your system to the limits of how many reads and writes it can do, you might have issues anyways. So you can't necessarily have strong guarantees in that regard. Then they were saying, even regardless of that, there's also the possibility that you end up with incorrect data in your database just because application code is wrong or something else goes wrong. You can have hardware fail in various different ways. We kind of assume that that stuff isn't going to happen, but even if you have all of the software stuff in line, in terms of the actual database itself, your application can mess up, or your hardware can mess up, or you can have any number of different things that go wrong still. One of the things they were mentioning is using sort of operation identifiers. And so if you're doing an operation that has to go through multiple systems or go through a long path, you can make sure that the operation goes through the whole chain of commands, and you can also make sure that it only happens once, because you don't want it failing partway through, and then it retries, and then it does it twice, and then it ends up twice on one system and only once on another, and then everything ends up out of sync, and your data is corrupted, basically. Then they talked about enforcing constraints. So there's a lot of different scenarios where you might have stuff where you just have to ensure that something never happens. So you don't let accounts go below zero. You don't sell stock that you don't have, for example, various different business constraints that you just can't allow to happen. And so they said that you can solve for these kind of constraints, but it can be kind of complicated. One of the systems they laid out was saying with log-based messaging that we've talked about in previous chapters, you can just make it require confirmation that certain things have actually occurred, and you can have it check at the time of the actual write to make sure that it is a valid thing for it to do, and you can stop it before something incorrect actually happens. Then they talked about timeliness and integrity. So that's something we've talked about a bit in previous chapters. And they were saying that there's different definitions of timeliness that are relevant for different use cases. So we've talked about the read on write and various different things, and it really just depends on exactly what use case you have, what will be relevant to your business specifically. And then they were able to define integrity a bit more in more general terms, saying that it's just the absence of data corruption. And one of the things they were pointing out is that integrity is more often than not more important than timeliness recently, because you end up in trouble if your data gets corrupted. But if your data is just not timely at this point, you can typically recover from that. If someone has information that is 30 seconds late or something, it's not a huge deal. So one of the things they were talking about is very often, even with those constraints, sometimes you can just get away with not actually enforcing them and just kind of apologize for them when they happen. So they talked about the scenario of overbooking on flights and stuff like that. You can just basically account for a certain amount of overbooking, and then you assume that some people aren't going to show up, and you are also able to just direct people to alternate flights and stuff like that. And they were also talking about usernames. So if two people sign up for the same username at the same time, then you can just have one go through and the other one say, hey, sorry, that username was already taken. And it's not the end of the world. You just have the user define their username again. Then they were talking about auditing and verifying that your data is actually correct. So a lot of these things we've talked about is trying to make sure that your data is correct, but you kind of just assume that this whole procedure is happening correctly, but you don't actually know until you look at your system and it has exactly inside of it what you expect it to. So they talked about trying to audit your data and making sure that it's correct. And they talked about a few different technologies in that regard. And they talked about backups. And so you periodically take backups of your databases and whatever other important data that you have, but then you have to actually try to use them sometimes and make sure that it's something that you can recover from and something you can actually use. Because it's not useful if it's just a file that's stored somewhere and not actually able to be used for recovery with. They talked a little bit about cryptocurrency stuff. So they mentioned Bitcoin, Ethereum, Ripple, a few other things. They're talking about how that's kind of solving some of these problems because you have large agreement on what data needs to be written and stuff like that. And that can kind of aid in verifying things. But one of the things they were noting is that a lot of those systems right now have very low throughput compared to what we typically have in our normal databases. Then in the last section, they were talking about doing the right thing. So this is kind of going along with the conversation we had earlier, which is you have to kind of consider the ethics of the data, its storage and its usage, and how it's going to be applied in the real world. So you have to be cognizant that it can be used in a biased way. It can be used for discrimination. That was exactly what we were discussing earlier about China and their various tactics and other tech companies and what they're doing. So one of the things that they brought up is that sometimes data can be used in opaque ways. So you pass it into a machine learning model, or you do some other operation on top of it that isn't easily understood. And then you can act like it's just making a human decision, but potentially with the human decision, you could actually query them and say, okay, why was this decision made? But if you're applying a machine learning model, you have no way of rectifying that potentially. And then they were talking about privacy and tracking. One of the things that they mentioned was just every time you use the word data, try plugging in the word surveillance instead and see how that feels. And so they kind of just laid things out and said that really a lot of what we're doing with data is akin to surveillance. We're capturing information about people, and then we're using it for various different uses. And we have to make sure that it's something that the people actually want and something that they're okay with. And if it's not something they want and it's not something they're okay with, then it's considered surveillance, basically. And sometimes that's a bit gray. So sometimes a user will explicitly say, okay, you can have my birthday and my email address, but then along with it, you go to a data broker and you buy all kinds of other information on them, or you capture their usage data and you learn a whole bunch of things about them. You store data in cookies and you figure out what websites they've been to. And so that was kind of the end of the chapter. Any questions, comments in our remaining 5 minutes?
I really liked that simple thing of just swap the word surveillance any place the word data appears. I think if you did that for just any generic discussion, it would immediately get people to be much more thoughtful, vigilant about stuff, you know?
I have a tweet, I think yesterday, ironically of all times, where it's like, hey, we should replace ML with automated bias to kind of evoke the same kind of, the same discussion, right?
Yes.
The same consideration.
Yes. No, I do think that it's a valid point, although I feel like I think this surveillance thing is very clever because, you know, technically it's not introducing some kind of slander, right? I mean, it is surveillance. You know, it doesn't have to be for evil. It could be surveillance so that Amazon knows when I need more printer ink, but it's still surveillance.
I think they should be more open about the overbooking, because a lot of people are hit by it, like a truck when they suddenly discovered it. I remember I read about it before flight, and when I encountered it, I was coming from Europe at this point, long flight. I said to the girl who looked rather exhausted behind the counter that I don't insist on getting another flight immediately. I am fine getting a voucher for a hotel and to spend the night. She was so happy,
Yeah, I mean, I think the other comment that was in the book is that, you know, there is no real negotiation between the application and the user. You know, it's accept this agreement or not, right? So either accept Facebook warts and all, or don't use it. But there's no like, well, I would like you to not use my data. You know, I want to use Facebook, but I don't want you to use my data in all the ways that you want to. There's no negotiation.
One of the clever phrases they had in the book was they said that machine learning was money laundering for bias, which I thought was also an interesting point, because it does kind of just it's just washing the dirty money.
This is a very good expression, yeah.
Yeah, I'm definitely learning a lot more, I would say recently. I mean, I'm impressed that this was written, you know, 3 years ago-ish, right? More recently, I'm learning a lot more about, again, like I understood explicit bias type stuff, you know? So like, but you know, there was some point in time early on when it was sort of like, oh, so if you just simply don't have race as one of the features in your model, then you should be, you know, way better off. And then coming to realize that no, because it's embedded in all the other features, that, you know, you can eliminate gender, you can eliminate race, but the model could be just as heavily biased. So it's like, oh wow.
Yeah, there is still
It's
laws.
actually a much harder problem.
There are still laws in place which does not allow to sell houses to Black people in some neighborhoods. They are now ignored in, well, in California, for example, but they're still here.
Yep.
So we're basically at time. Any closing remarks on the book? I thought that
I just wanted to say thanks so much for both Ryan and Ted for setting up everything and taking those notes. I fell behind quite a bit because I was a bit busy, but those notes were super helpful.
Yes, it was very educational. I'm very grateful as well for these people taking the bulk of the work over the book.
Yeah, and going through all those exoteric details.
Well, thanks. Yeah, I mean, this book obviously was not super directly ML related, but I definitely feel like I learned a lot. And again, you know, I've been doing database work for a long time, and even though we weren't doing distributed stuff, but there's stuff that I just assumed was guaranteed, and actually, you know, default behavior on a regular SQL database, it does not absolutely guarantee against these race conditions, because we were not running it serializable. We were just running it with whatever the default read committed or whatever. And so it's like, I didn't know that. I would say, Ryan, at least for me, I'm definitely ready, whatever we do next, to do something much more directly.
Yeah.
Go back to much more directly machine learning. I mean, not that I don't regret it at all, and we may do other things that are, again, more data engineering, more, you know, whatever. But yeah, back to more our core.
Yeah. Well, for me, it's a balance between learning what is useful and is valuable, and learning the stuff that I'm interested in and think is fun. I can definitely see how this is valuable stuff, but it's not necessarily the stuff that I like enjoy as much. I definitely enjoy the like algorithmic machine learning side of things more.